All right, welcome back. In this section, we are going to go over some of the processes and workflows that we'll use when we are building our Stacks projects locally. So we went over and kind of looked at the Hero platform powered DevNet, and we kind of got an overview of all the different components of the Stacks developer ecosystem and kind of the stack that you'll be using. And today we're really going to dig into one of those, which is Clarinet. And so what I recommend doing is following along in the documentation, because what I'm basically going to be doing is going through each of these features in the documentation. We're going to kind of run through and see how we can use them in our contract that we have, our fundraising contract that we have. So if you go to the docs.stacks.co, go over to the build section, you'll see this learn Clarinet section. And this is where we're going to be spending our time today. And so quick recap of what Clarinet actually is Clarinet is a developer tool that's going to allow you to work with your Clarity smart contracts locally. It's going to allow you to, it's going to help make writing them and formatting them easier. You can check syntax, check for errors, spin up a simulated developer environment that we'll cover today for just quickly running through and testing things. You'll also use Clarinet to deploy your smart contracts. And then Clarinet also has a built-in devnet. So if you would prefer not to use the hosted Hero platform version of devnet, you can actually run devnet using Clarinet itself, which will run on your local machine rather than in the cloud environment of the Hero platform. So that's also an option. But we're going to go through and look at all these different things today. So if you don't already, install Clarinet. We've got installation instructions here depending on your operating system. I'm using a Mac, and so you can just run quick brew install Clarinet here. Clarinet's got supports different kinds of networks. So DevNet is what you're going to be mainly working in when you're actually developing your contract and testing it locally. DevNet is the network that's running on the platform. Simnet is what is going to be used for like unit testing. So when you write your tests, every time you run your testing suite, it's going to spin up a Simnet environment and use that to run through your tests. And then testnet and mainnet are what you'd expect. These are the publicly deployed and accessible testnets and mainnets for Stacks. So if we go over here to the quick start, we can look at a couple of the basics. We're actually not going to use these today because these right here are how you actually create a new project. And since we already have a project, we're not going to be doing that. But right here, I'm going to spend a lot of time in the terminal today. But you can see we're inside our CrowdForge Clarity folder. This Clarity folder is where we actually have our Clarinet set up here. But if I were to start a new project, what I could do here is run Clarinet new. We'd run new project there. What that's going to do is that's going to create this folder with all this structure here. And then if I were to create a new contract within this folder, I would run this Clarinet contract new command within this folder. And that's going to create a new contract. And what that's going to do is it's also going to add the requirement for that contract to our TOML file. It's going to create it in the right place in the contracts folder, and it's going to create a stub test file for it. So that's what that would do there. You can see we've got a walkthrough of the actual structure here. We went through a lot of this last time, so I won't go into it in too much detail. But that's what you would do here to generate a new contract. And then obviously you generate it, and you just go in there and write your Clarity code. We're going to dig into Clarity itself in the next lesson. So a couple things that you can do with Clarinet that are super helpful for actually developing your contracts. The first thing I'd recommend doing that's related to Clarinet is in your editor, I highly recommend installing the Clarity extension. So I'm in here in Google Anti-Gravity, which is a VS Code fork, as most editors are these days. And so here, if you go to the extension marketplace, just search Clarity, and I highly recommend installing this for a couple reasons. The first is just that it's going to provide much cleaner syntax highlighting and theme here, so you can makes your Clarity code a lot more readable. But the other thing that it provides that is really cool is it will also allow you to auto format your contracts on save. So let's say I mess up the formatting here, do something like this, and then this is all over the place. What I can do is with the Clarity extension in VS Code, when I hit save, of course it's not working because I have an error here because of this white space. The Clarity and Clarinet interpreter will throw errors if your white space is messed up, like if you shove two function calls together like this. But this is still incorrectly formatted, so if I fix that error that I actually got and hit save, then you can see it's going to auto format that here. But relating to that error, you'll also see that that was actually highlighted there. So let's say, for example, if I get rid of this asserts function and I say fake function, something that doesn't actually exist, hit save, you can see I'm going to get an error highlighted here within my begin function. Again, we'll go over Clarity basics a little bit more in the next lesson if you're not already familiar with them, but highlight this right here and it's going to say use of unresolved function, fake function, and Clarity right here. The other thing that I can do is, so that's how you can kind of check your Clarity contracts within the editor itself using the Clarity extension. So I highly recommend everybody install that. But also within Clarinet, what I can do is I can run clarinet check. I'm going to say no right here. So what this is doing right here is this is saying a new deployment plan was computed and differs from the default deployment plan currently saved on disk. Generally, when we're using these platform templates, we don't want to overwrite this because there are specific things set up in place to allow us to deploy this correctly. But what this is basically saying is it can generate a new deployment plan for us based on the setup that we have in our clarinet.toml settings file. And so the deployment plan that's going to be generating here is just a deployment plan for devnet. So the way that devnet works is it's actually creating and spinning up an actual simulated blockchain environment. And so it still needs a deployment plan because we're telling our devnet environment how we want to deploy all of our contracts. And so what this is basically saying is we're going to deploy these SBTC contracts and then we're going to deploy our fundraising contract. But I'm going to say no here because we want to use the deployment plan that came with the platform template. And you can see here when I ran clarinet check, we got that same error, use of unresolved function, fake function. So if I go back and I fix this and I make it in asserts, save it, you can see that goes away. We've got no errors here. And then if I run clarinet check, no, don't overwrite that. Then you can see 4 contracts checked and we've got that green check mark because we're all good. So that's one of the things you can do with Clarinet is run through and check the formatting of your contract. Clarinet Console. This is another one that you'll probably end up using a lot. And so this is what we're going to spend a lot of our time doing today. But let's keep going through these real quick. Project structure, pretty self-explanatory. We kind of went over this last time. You can see how Clarinet projects are structured in here in this section. Project development. This is going to kind of go through the workflow of actually working on a Clarity project using Clarinet. So we've got here creating the new ones that we talked about, creating a new contract, checking the syntax, which is what we just did. You can check a specific contract syntax. The other thing that you can do is the Clarity extension within the editor has the formatter in it, but you can also manually format using this command right here. So this clarinet format command will do something similar. You can check out the different parameters for how to adjust that here. Project configuration. So this is one of the things that you'll want to become familiar with. Clarity contracts are not object-oriented like Solidity contracts are. They work a little bit differently. They work with something, it's called composition. And so basically what Clarity contracts will do is rather than like inheriting the functionality of a class like you would in an object-oriented language, you can do one of two things in Clarity contracts. You can either call contracts directly, or you can basically make your contract conform to a trait. And you can think of a trait like a contract template that your contract wants to fit with. We're not going to get into the details of that right now. We'll touch on it in the next lesson, but I also highly recommend going and reading the Clarity book if you haven't yet. And we also have a Clarity quick start in the docs as well. But for Clarinet's context specifically, what we need to make sure that we do in our local environment is if one of our contracts calls into or relies on another contract, say one that's deployed on mainnet, like the SBTC contract, we need a way to tell Clarinet to pull that contract in. And so there's one way that we can do that is through the CLI. We can just run this Clarinet requirements add, and then we can put the contract in here from the address from the Explorer. So if we go in and check our clarinet.toml file here, we can see this project.requirements section, and we can see this contract ID, and this is a deployed mainnet contract. So if I were to take this, go to the Explorer, paste this in here, and go visit it, this is the deployed SBTC token contract that's live on mainnet. And so what I can do in Clarinet is I can tell Clarinet I actually need to be able to call that contract from the contract that I'm developing. And so what I can do there is I can run that Clarinet requirements add command, and that will then add it to the list of requirements here, so that then when I'm in my fundraising contract, I can actually call that contract directly, even though I'm only in my local devnet environment. So what this is basically doing is it allows you to take a contract that's deployed on testnet or mainnet, and it allows you to pull it down into your contract without needing to manually create like a mock version of it here in your contracts folder. So it allows you to get access to that contract functionality so that you can test calls with it from within your local contract, which is really, really nice, because then it means you don't need to like refactor your contract here later with like a test stub contract and everything like that. So that's what this working with requirements is actually doing here, is that I'll add that there. And then you can also see you can do the same thing with traits here. So the way that you implement a trait, the way that you tell a contract that it needs to conform to a specific traits template, is you use this implement trait function here. And so this call right here, because this is a deployed mainnet contract, you can tell because it starts with either SP or SM, this would fail and return an error if we didn't first require that contract in our clarinet.toml file, if we were to use this on a devnet deployment. So that's what we can do there. Contract interaction, Clarinet Console. There is a lot you can do with Clarinet Console. So I find that the best and easiest way to test contracts as you're developing them is to use the Clarinet Console. So we've got our fundraising contract here. And if we wanted to test this out and see how it's working, a lot of the time the best way to do that is to run this Clarinet Console. And when I say test it out, I'm not talking about like an automated test suite, like that's what we're going to do in a separate video. That's a different thing. What I'm talking about here is like manually testing out and interacting with your contract as a user would if they were calling into it. So we can run Clarinet Console here, don't want to overwrite. When we run Clarinet Console, this is actually deploying a Simnet network. So this is just like our unit test and integration test. This is going to use that same Simnet deployment plan. But this is also a mini localized version of the Stacks blockchain. It doesn't have as much of like the one-to-one block production functionality and like timing mocks as the devnet does. Devnet is going to be much more useful for when you need to test like your UI and make sure that your UI is working with the contracts correctly, because then you can call into your contracts on the mock chain using things like Stacks.js. But what Clarinet Console is good for is for you to manually test your contract calls directly. So you can see here it's showing us what has deployed. So we've got our fundraising contract here that's been deployed, and we have a list of all the public functions that we can call on it. You can also see we've got a series of test addresses which have a certain amount of tokens already in them. So the first thing that you should do here is actually run this : help command, because Clarinet Console, once you're in it, it has a bunch of different commands that you can run within Clarinet Console to help you work with your contracts. So if you run this help command, it'll show you what all those are. So what we can do is we can say functions here, and that's going to give us all of the different functions that we have available in Clarity. Let's run that again, go through a couple of those other ones. Keywords would do the same thing. Describe function, this is actually going to allow us to get the documentation for a function or keyword. Toggle costs, what this is going to do is this is going to make it so that we can show how much each function call actually costs us in runtime execution costs. We can do that directly here from the console. Same thing with timings. There's a built-in mint stacks function and a mint fungible token function. Set transaction sender, this is one that you're probably going to use a lot. So if you want to call into one of your functions from a specific address, you can manually set that right here. Get asset maps, this is a useful one for displaying how many tokens each address owns. That's in this little mock Simnet right here. Get contracts will do the same thing. Get block height, we'll do the current block height. Another useful one that you'll probably use all the time is advancing the chain tip. And what this is going to allow you to do is test and simulate time or block-based functionality in your contract. So for example, there's a token streaming contract that I use a lot in examples. And what that does is basically says, I want to pay this address this many STX tokens or SBTC tokens over this many blocks. And so what this will allow us to do is manually advance the chain a certain number of blocks so that we can test that kind of functionality. And then we've got a bunch of other different things that we can do here. Set the epoch, get the epoch. We can debug, which is really cool. What this will allow us to do is start an interactive debug session. So we can call debug. Let's look at the documentation here. And we're going to go to local blockchain development, because this is where a lot of the stuff that we're going to see in the console is actually, it's in this contract interaction section, I think. Where am I here? Working with contracts, different principles, block heights, validation and analysis. There. So this validation and analysis section is going to have a bunch of different useful things that you can do. So this is going to kind of show us how we can do some of this runtime analysis that we were talking about, where we can do toggle costs, and we can call one of these functions. So let's go ahead and try this out. I'm going to run this toggle costs function. Always show costs true. And so let's see, let's check out our functions here in fundraising, and let's try and initialize a campaign. So we need a goal that is a uint and a duration that is a uint. So what I'm going to do within the console now is I'm going to use this contract call function. So this is just all I'm doing right now is within the console, I'm calling a built-in Clarity function, contract call, and then I'm going to call my fundraising contract, and I want to call the initialize campaign. And we need two parameters here. We need a goal and a duration. And I believe the duration, goal is in US dollars, past duration is 0 to use the default duration, which is about 30 days. Okay, so we're just going to go with that. We're going to say the goal is $500, and we're going to do exactly what it says, past 0 to go with the default duration of 30 days. We're going to call that. We're going to see if it works. So it worked because we got this OK true. If we go to our function here, that's what it's going to return at the end to us here. And you can also see that we have a little bit of a cost analysis of what running this function actually cost us. And so this is going to be really helpful for going through and trying to figure out where you can make different optimizations in your actual contract. Same thing, something similar is trace and debug. These are just going to allow you to run through your contract calls and see where you might need to edit and refine things. So what you're going to do is just prepend this function to whatever contract call you're making. So if I wanted to run this again with trace, I can run that right here. And now I'm getting an error. Let's see what this error 106 is. So error already initialized. So I'm actually going to exit out of this, rerun it again, don't overwrite, and now I'm going to say trace, and I'm going to paste that in there. Okay, true. And the reason this is only showing this here is because we're not calling into any other functions within here. But if you look at the example here for trace, you can see if it needs to call into other functions to do things to go through its contract call, it's going to show you each stage of what's actually happening and which other contract functions are being called when you call that one. The other thing that we can do is debug. And I'm going to need to close this out again. Clarinet Console, don't overwrite. And I'm going to say debug, and I'm going to do the same contract call. And so what this is going to allow you to do is this is going to bring up like an interactive session that's actually going to go through and execute each line of your contract one at a time. And so we've got some navigation commands here. So while I am in this debugging session, we can do S to step into sub-expressions. We can complete the current expression, step over, or resume execution. So I'm going to run S here, and that's just going to allow us to step through each chunk of this. So I can hit S again, run through, see what is actually happening at each step of this. And you can see how granular this is. It's going through every single session, and I can run F to finish it up. So this is really good because it's going to allow you to kind of see what is actually happening at each stage, and it'll allow you to debug if your contract's running into an error and you're not sure where. Going through it step by step like this is a really good way to kind of debug it and figure it out. Get costs is the same thing as toggle costs. This is just going to allow you to do it one-off. And then, yeah, this trace is going to allow you to kind of see exactly like, okay, where specifically do I need to change which contract call is being called here. So definitely recommend running through this documentation to kind of check this out. But the Clarinet Console is going to be probably your go-to for manually interacting with and testing your contracts quickly while you're developing them to make sure the functionality is working exactly how you expect. So definitely get comfortable using the console for that. We went through the Clarity formatter for both. Local blockchain development, this is what I was talking about. If you don't want to use the platform's cloud devnet, then you can run it yourself using this Clarinet devnet start command. It's going to be very similar functionality. It's just that this is going to give you a little bit more control over the devnet if you need it, with the trade-off that you're going to have to run it on your local computer. So just depending on what kind of setup you want is how you use that there. And then we're going to have an entire video and session on deploying contracts, but we're going to do that through Clarinet. But we're going to go through and we're going to have a separate section on that later. So that's sort of like the local stacks development workflow. Is you use the devnet, you build your front end, you connect your front end to the devnet like we saw in the template. But for the actual Clarity piece of things, you're really going to lean on the Clarinet Console a lot to actually go through and help you really work on and debug and make sure the functionality for your contracts are working correctly. So with that said, in the next video, we're going to take this process of actually like using the console and working with our Clarity contracts, and we're going to add a new function to our existing Clarity contract and go over some of the basics of Clarity and actually go through this workflow live while we add a new feature to our Clarity contract. So I'll see you there.